In this video, we will practice using our set notation with our and or, and not, and we will do some probability. We will also get comfortable with our vocabulary, things like independent versus dependent, and mutually exclusive versus overlapping. So let's start with that vocabulary. Problem number 1 says, circle all pairs that are independent. If two events are independent, that means that the outcome of one event has no effect on the other event. So if you're flipping a coin and rolling a die, getting tails from the coin and getting a 4 from the die, those are definitely independent because one will have no effect on the other. Rolling a red die and a green die, getting a 4 on the red die, getting a 4 on the green die, again, those are independent. One has no effect on the other. Now, when we're drawing cards, here's where we have a chance at having some dependent. Okay? The dependent happens when you take out a card and you don't put it back. So, for example, these events will be dependent because as soon as you take out a card and you don't put it back, that changes the probability for the second event because you have fewer cards. On the other hand, as long as they say with replacement, you are still going to have independent events because you're putting the card back. So you're starting fresh, you're starting over. So that erases any effect that one event might have on the other. So these first 3 are all independent, but the last one is dependent. Now, which of the following describes a pair of events A and B that are mutually exclusive? Mutually exclusive means that both events cannot happen at the same time or to the same person. Okay, so if one event is owning a guitar and another event is owning a violin, those are not mutually exclusive because a person could own a guitar and a violin. Wearing jeans and wearing a sweater, those are not mutually exclusive because you can picture a person wearing jeans and wearing a sweater. Okay, having math first period, having band first period. These are mutually exclusive because your first period class cannot be both math and band. You're either going to have one or the other. Having math first period and band sixth period. Those are not mutually exclusive because both of these could happen. You could have math first period and you could have band sixth period. There's no conflict there. All right, moving on to number 3. Let C equal the event graduated from college. Let H be graduated from high school. Which of these describes people who graduated from high school but not from college? Okay, first of all, this but is a hidden and. All right, we're really describing 2 things that are both happening. They're graduating from high school, and at the same time, they did not graduate from college. So this is another way of saying and. So we need graduating from high school, but not college. So this is what I'm looking for, and that is option A. Whoops, that's or. Let me try that again. I meant this is what I'm looking for. Okay, problem number 4. If you roll a 6-sided die 2 times, what is the probability that you'll get a 4 on the first roll and an odd number on the second roll? Okay, the probability of 2 things happening in a row, you multiply. So it's going to be the probability of, all right, we're getting a 4 first. So I'll say 4 first. And we're going to multiply that times the probability of getting an odd number on the second roll. So I'll just say odd second. All right, when you're talking about two things happening in a row, that you use the multiplication rule. So the probability of getting a 4 on the first roll is a 1 out of 6, all right, because there's one 4 on the die and it has 6 sides. Now the probability of getting an odd number on the second roll is 3 out of 6. All right, because there are 3 odd numbers out of a total of 6. If you multiply those together, you multiply straight across, so that's going to be 3 over 36. And then this reduces down to 1 out of 12. All right, so the probability, the answer is going to be B, 1/12. Okay, we've got a little Venn diagram here. The Good Eats Club looked at the lunches that 50 students brought from home to see what they had brought. The results are displayed in this Venn diagram. F equals the lunch included fruit. V, the lunch includes vegetables. Use this Venn diagram to answer the questions below. Find the probability, all right, that P stands for probability. So as soon as I see probability, I'm thinking, oh, okay, target over total, because that's what probability means. So what's the total? The total is going to be 50, all right, because it's 50 students. These 4 numbers all add up to 50. So I know I'm going to be doing 50 right here. Now, what's the target? F or V. When you do or, you just take all of both sets. So F or V looks like this. All right, F or V is just, you just highlight everything mentioned. So if I add those up, 7 plus 3 is 10, so that's 22. All right, so that's 22 out of 50. All right, we could just reduce that just for fun. 22 out of 50. Okay, it's 11 out of 25. All right, but I would accept either one. All right, let me erase that highlighting to get ready for the next problem. Find the probability of F given V. I love given problems because whatever is given turns out to be the new total. And the other part is the target. Okay, so we are given V, so that is the new total. So that means this, my friends, is the new total. All right, if this is the new total, then that means no other numbers exist. So we can forget about the 7 and the 28. This is the new total. Cross out everything else. So since probability is target over total, okay, the new total is 15. Now what's the target? So the target is F. Now normally F would be the 7 and the 3, but I crossed out the 7 because that's not part of the total anymore. So all that's left, the only F number that survived is the number 3. So this 3 is the target. So that's why it's going to be 3 out of 15, which is 1 out of 5. Okay. All right, we have several things to find now. I feel like I should erase all this to get ready for the coming storm. All right, probability of F. All of these have a P in front of it for probability, so all of these are going to be fractions. Okay, so the probability of F, well, F is this right here. Boom. All right, that's 10. So the probability of F is going to be 10 out of 50, which reduces down, of course, to 1 out of 5. What about the probability of V? V is this one. All right, that's 15. So the probability of V is going to be 15 out of 50. That's 3 out of 10. Okay, now the probability of F and V. Well, F and V is the overlap between F and V. Okay, F and V is just this part right here, the overlap. So that is 3. So that's going to be 3 out of 50. Okay. Number 8. Use your answers to the previous question to determine whether F and V are independent or dependent. Well, if we want to determine if two events are independent, we have to use the following formula. We have to check and see. If we multiply the probability of F times the probability of V, does that equal the probability of F and V? If it does, okay, if this is true, that means F and V are independent. Okay, if this is false, that means that F and V are dependent. All right, so we have to check and see. So the probability of F, that was 1/5. The probability of V, that was 3/10. The probability of F and V, that was 3/50. So I'm going to put a question mark here because we don't know if these are equal. We're checking. But if you multiply this out, 1 times 3 is 3, and 5 times 10 is 50. So 3 out of 50 equals 3 out of 50. So yes, that's true. So therefore, like I said, if we got a true statement, that would mean that they are independent. So we will circle independent. An advertising company tested 3 versions, A, B, and C, of a commercial for a product. They showed the versions to 3 separate groups. Then they asked participants if they were likely to buy the product. The results are shown below. Okay, so we had 3 different commercials shown to 3 different groups. And some said yes, they were likely to buy it. Some said no. Apparently, a total of 100 people were questioned. So, how many participants watched version A of the commercial? Well, that's this 30 right here. All right, 30 participants watched version A of the commercial. Okay. Find the probability of n and not a. N and not a. So when I see and, that tells me to use two colors and look for the overlap. So let's start with n. All right, here is row n. Just highlight it. Okay, now I'm going to switch colors and I'm going to highlight not a. That means I'm going to highlight everything that is not a. A is the first column, so that's why I'm highlighting the other two columns, because they are not A. Okay? Now, I did it this way because when you do and, you're looking for the overlapping part, which will show up as green. So these two squares are the overlapping part. This is a probability problem, which means that we have to do target over total. The total is 100, all right? There was 100 participants. So I'm going to put 100 for the total. Now the target is showing up here in green, as I mentioned. Just looking at what those numbers were, that's 9 and 24, so that's 33. All right, so that's 33 out of 100. Okay, which is the same thing as 33%, if anybody cares. Moving on. So when I do and, I do two colors and I use the overlapping part only. When I see an or problem, which is what this is, then I only use one color. I use one color for everything because when you're doing or, you just want all of everything. So I'm going to highlight N in yellow. Boom. Okay. And then I'm going to highlight not A in yellow also. So not A. So here's A. So not A is over here. Okay. And for an or problem, you just keep everything you just highlighted. So this is still probability, so we're still doing target over total. The total is still 100, but the target is all 5 of these squares. Notice that it's everything except for the upper left-hand corner. All right, everything except for the 17. So let's see, if I subtract 20, that would be 80. But since I'm only subtracting 17, that should be 83. All right, so I just did a quick shortcut there to save me from having to add up those 5 numbers separately. But if I add up these 5 numbers right here, it should come out to be 83. All right, so there you go. I don't think that reduces even. So I'm just going to put 83 out of 100, which of course would be 83%. Okay. All right. I haven't highlighted anything yet. Great. The probability of y given c. I love given problems because the given part becomes the new total and the first part is the target. So when you have a given problem, you always start with the new total, which will be C. So this is the new total right here. And when you have a new total, you have to cross out everything else, all right? Because that's gone now. This is the new total. So for probability, we're always doing target over total. The new total is the C column. So looking up there, that's 50. So my new total is 50. Now, the target is Y. So I'm not going to highlight all 3 squares because I crossed out 2 of them. All right, they're not coming back. So I'm only going to wind up highlighting this square, which is y. So that is 26. Okay, so that's going to be 26 out of 50. I'm pretty sure that reduces. That's 13 out of 25. Which is 52%. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.